Hey everyone, so this will be the first of a series of videos going over all the problems in the 2019 F equals MA test. Alright, so let's begin with problem number 1, which is asking for the work done, how much energy is dissipated due to friction when a block roll slides down an incline. So let's first think about what this question is asking for and what it really means. So the block initially starts with some energy, probably gravitational potential energy when it's raised. And energy is conserved, so whatever energy initial it has, then also it has to go into energy final. However, what's going on is that energy is being dissipated due to friction. Does this mean that energy is not conserved? No, because what this means is that energy is just going into the work done by friction. So what we can write is actually that in the energy final section, so we have an initial energy without any energy loss due to friction, and then in the energy final we have the energy final in the kinetic energy, and we also have some energy that's going into the internal energy of the system that's caused by friction. So I'm going to say internal. And how we can find this is actually by using work. So we know that work is equal to force times distance, right? So if we figure out what's the force of friction and over how much distance it acts over, then we can figure out how much work is done by friction, and how much work is done by friction goes into internal energy, right? So, and that's actually how much energy is being dissipated due to friction. So now all we have to do is figure out the force and the distance that friction acts. And we are given that the distance that friction acts is over this incline of length 10 meters that has these coefficients of friction right here, right? And then afterwards it goes into a frictionless horizontal surface, so we don't need to worry about that. So now the only job for us to do is to figure out the force due to friction. And how we do that is we have to first look at the force diagram and see which kinetic energy or static friction do we use. Actually, it turns out that static friction does not give any internal energy. Static friction doesn't do any work because distance does not change if it's static friction. So we already know that it's kinetic energy. But anyways, let's go and draw the force diagram. So here's the situation. We have a 30-degree incline, and then we have a block right here. And here the force diagram, we have the gravity going straight down, we have the normal force going like that, and we have the friction force going like that, and this is a 30-degree. So if we tilt the reference frame so that the normal force points straight up, I'm going to call this N, and then the friction force, lowercase f, and then the gravitational force, which is equal to 10 kilograms times the gravitational field strength, which we are approximating to be 10, because that's what the rules tells us to, so it gives us 100 newtons for the force of gravity. And we know that this is at a 30-degree incline, so that means that the x component of the gravitational force is going to be 50 newtons, right? Sine of 30 degrees, which is 1/2 times 100, is equal to 50. And we also know that the y component of gravity, which is Fg times cosine of 30 degrees, is equal to 86.6 newtons, okay? Now we know that since it's not moving in the y direction, we know that the net force in the y direction has to be 0, which means that force of normal is equal to the 86.6 newtons, right? These two forces cancel out. And now we can figure out the force of friction, because force of friction is equal to the kinetic friction coefficient times the force of the normal force, and that's equal to 0.1 times 86.6, which is equal to 8.66 newtons. Now we know that, remember, we're trying to look for the work done by the frictional force, and we know that this is the force of friction, so work is equal to 8.66 times 10. 10 is the length of the incline, And that gives us the final answer, which is 86.6 joules of work being done by the force of friction. So that gives us answer choice B, which is rounded to the nearest integer, 87 joules.